Hello friends, in the last lecture we have discussed about the non-head-on collision, that is the two-dimensional collision. Now in this lecture we are going to discuss about a problem.
Bullets of mass 40 gram each are fired from a machine gun at a rate of 5 per second towards a firmly fixed hard surface of area 10 centimeters square. Each bullet hits normal to the surface at 400 meters per second and rebounds in such a way that the coefficient of restitution for the collision between bullet and the surface is 0.75. Calculate average force and average pressure experienced by the surface due to this firing.
Now the mass of the bullet is 40 gram given in the problem. But it is 40 gram. So now we want to do the problem in the SI system. So 40, we know that 1 gram is 10 to the power minus 3 kg. So we write it 40 into 10 to the power minus 3 kg. So we absorb this minus 3 inside here. So we get 0.04 kg. So the mass of bullet, which is 40 gram, is 0.04 kg. Now the velocity of the bullet, which is coming from the gun, is U1 is 400 meters per second. Now this bullet is hitting a hard surface. The area of the fixed hard surface is given is 10 centimeters square. Now again, this is in the CGS system and we want to solve the problem in the SI system. So now we know that 1 centimeter is equal to 10 to the power minus 2 meter. So 1 centimeter square will be 10 to the power minus 2 meter square. So this is 10 into this centimeter square. So for this centimeter square, I write 10 to the power minus 2 meter square. So I write 10 to the power minus 2 meter square. So I get 10. This 10 to the power minus 2 square is minus 4. So 10 to the power minus 4 and meter square. So we absorb it here. So we get the answer as the area of the fixed hard surface is 10 to the power minus 3 meter square. Now this bullet is hitting on the very hard surface. The coefficient of restitution is given is 0.75. They have asked us to find the average force and the average pressure experienced by the surface due to the firing of the bullet, which is 5 bullets are fired in 1 second. Now, initially, before finding the force and the pressure, we would be finding the rebound velocity of the bullet. Now we know that 1 is the velocity, initial velocity of the bullet, which is 400 meter per second. And U2, the initial velocity of the hard surface, is 0 meter per second because it is very hard. Also, when the bullet hits on this hard surface, it rebounds and there is no motion of the hard surface. So the final velocity V2 of the hard surface is also 0 meters per second. So now we would be finding the final velocity of the bullet. Now the coefficient of restitution E is V1 minus V2 upon U2 minus U1. So the coefficient of restitution given is 0.75. So now V1 we don't know. We have to find the final velocity of the bullet minus V2. The final velocity of the hard surface is 0 upon U2. The final initial velocity of the hard surface is 0 minus U1. Initial velocity of the bullet is 400. So this is equal to V1 upon minus 400. Therefore, V1 is equal to 0.75 into minus 400. That is equal to minus 300. So, minus 300 meters per second is the final velocity of the bullet. Minus sign indicates that the initial direction and the direction now, the initial velocity and final velocity are in the opposite direction because the bullet is rebounding in the opposite direction. Now, the change in momentum of the bullet is final momentum of the bullet minus initial momentum of the bullet. That is equal to m1 v1 minus m1 u1. That is equal to m1 v1 minus u1. That is equal to m1 is 0.04 kg. v1 is the final velocity, which is minus 300 minus 400. That is equal to 0.04, that is minus 700. So, that is equal to 4 into 7 into 10 to the power minus 2 into 10 to the power plus 2. This is equal to minus 28 Newton second is the change in the momentum of the bullet. Now, what does this minus sign indicate? That the momentum is lost by the bullet. There is a decrease in momentum of the bullet. Now, the momentum which is lost by the bullet, then the momentum gained by the surface is therefore momentum gained by the surface is plus 28 Newton second. This is the momentum gained by the surface. Now, we know that the frequency with which the bullet is fired is 5 bullets in 1 second. So, this is the momentum gained by the surface due to the collision of only one bullet. But how many bullets are fired in 1 second? There are 5 bullets. 5 bullets are fired in 1 second. So, the momentum gained by the surface in 1 second, momentum gained by the surface in 1 second is equal to plus 28 into 5. That is equal to 140 Newton. Now, according to the Newton's second law of motion, the change in momentum per unit time is the force. So, according to the Newton's, so this is the force. So, the force experienced by, so the average force experienced by the surface due to the firing is 140 Newton is the average force. So, according to the Newton's second law of motion, the rate of change of linear momentum of a rigid body is directly proportional to the applied force and takes place in the direction of the force. And hence, with the help of this definition, we can say that the momentum gained by the surface per second is the force which is experienced by the surface during the firing. Hence, the force experienced by the surface during the firing is 140 Newton. So, the average force of 140 Newton is exerted on a fixed hard surface of area A, which is equal to 10 to the power minus 3 meters square. Now we know. Now we want to find the average pressure experienced by the surface during the firing. So, we know that pressure is equal to force upon area. So, the force is 140 Newton and the area is 10 to the power minus 3, that is 140 into 10 to the power 3 Newton per meter square, that is equal to 1.4 into 10 to the power 5 Newton per meter square is the average pressure experienced by the surface during firing. The next point which we are going to discuss is the impulse of a force. Now, according to the Newton's second law of motion, the rate of change of linear momentum of a rigid body is directly proportional to the applied force and takes place in the direction of the force. So this statement, when we write it mathematically for the Newton's second law, it is like F is equal to dP by dt. Now we rearrange it. So dP is equal to F into dt. So dP is the change in momentum, that is equal to force into the time. So this change in momentum is now given a new name as the impulse of the force. So the change in momentum is called as the impulse of the force. That is the final momentum minus initial momentum, which is equal to the F into T. Now, so this J is equal to PF minus PI. Now P is final momentum, that is M into V, and Pi is initial momentum, that is M into U. So it can also be written as M into V minus U. So the one more formula for J is M into V minus U, or we can write it as also F into T. So these are the formulas for the impulse of a force. Now, here it is considered that the force is a constant quantity. Constant force is applied. But if the force is not constant, then what is to be done? So when the force is not a constant quantity, it is a changing force. So at that time, J will be equal to integral of dP. That is equal to integral of F into dt. Now, what is the reason for taking the integration? Here, so this J is the change in momentum, this P1 plus P2 plus P3 dot dot up to Pn. Now, since the force is changing, so the momentum is changing. Now, P1 is the change in momentum, but the instantaneous force is constant. We can consider that for that instant the force is constant. So here we are discussing about, we are adding the momentums when that instantaneous force is constant, because this formula is for a constant force. So here we are integrating, meaning we are adding the change in momentum, but for this P1, that instantaneous force is a constant. For P2, the instantaneous force is constant. Similarly, dot dot up to Pn, how many times the force is changing? For that, you will have to find the change in, so many times you will have to find the change in momentum. So this J, instead of adding all such, we use the mathematics, the integration part of the mathematics, that is we integrate. So the integral of dP, that is integral of F dt, with the help of this integration, if the force is varying, then and then also we can find the impulse of the force. Thank you.